So we have this exponential Diophontaine equation on the board. We have 2 to the m minus 2 to the n equals 124. We're looking for integer solutions only. Some of you might just guess and check this and get it pretty quick, but it's a more interesting problem if we can solve it systematically. So let's try that. First we want the primary factorization of the right side, and that's going to be 2 squared times 31. 4 times 31 is 124. That's gonna help us out quite a bit. Now, looking at the left side, what we can do is we can factor out a 2n. Kind of always the same process here. What we do is we're going to assume, I'm assuming n is less than or equal to m. Because if n's greater, then we have a negative number, and we can't have that. So, and I do that even if this is addition. We make an assumption that addition's a little different, but you still make the assumption you want to set up so you can factor out one of these. So we'll factor out the 2 to the n. And this will factor like this. Now next, this is perfect because we have an even number and we have an odd number. This is just a product of two numbers, and there's a few different ways, right? There's not just, so like, okay, if we were to look at all the ways that we could get 124 as a product of two numbers, it could be a lot of things. It could be 1 times 124. It could be 2 times 62. I guess it couldn't be that many things, right? Because we have a pretty small factorization here. What else? I think that's it. Is that it? Yeah, I think that's it. I mean, obviously you could order them differently, and that's important in this case because we got two very different expressions. So we'll get the opposite of each of these. But a lot of these are impossible because, so like, first of all, 31 times 2 squared is impossible because this is even and this is odd, and we end up with the opposite. 31 is odd, 2 squared is even, so that's not going to work. So right off the bat, we'll eliminate that case. I know this is kind of excessive, but I just feel like walking through all the possibilities. Like 62 is not a power of 2, so we can cancel that out. 124 is not a power of 2, we can cancel that out. 1, we can't have 1 there. Well, actually, we could have 1 there, because we could have 2 to the 0. We could have 2 to the 0, but the only thing is this second number needs to be odd, and 124 is not odd, so that's not a possibility. So we're down to 2 cases. Again, here, same problem. 2 is a power of 2, obviously, but 62 is even. So we really just have 1 possibility. So let's confirm that that works. So if we have 2 squared times 31, now that means n equals 2, right? Just equating this to this. N equals 2. And then in this equation, we're saying 2 to the m minus n minus 1 equals 31. Now, but we know that n is 2, so let's plug that in. At the same time we're plugging that in, let's move move that 1 over there, adding 1 to both sides. So we see that 2 to the m minus 2, sorry, we replaced it with a 2, equals 32. Now, as power of 2, we can write 32 as 2 to the 5th. Now we have the same base, so we can equate the exponents. So we're saying that m minus 2 equals 5, adding 2 to both sides, m equals 7. So that's it, we have m equals 7 and n equals 2. And then let's just confirm that works, plugging back into our original equation right here. So we're going to say that 2 to the 7th minus 2 squared equals 124. 2 to the 7th is 128. 2 to the 4th is 4. And that equals 124. So perfect. That works.